Good morning, class 12th. In the subject mathematics today, we will continue our integration, and in integration also, we will do our concluding method, that is integration by partial fraction method. So this is another method which is your concluding one to find the integration of given functions. So particularly this method is applied when you have a rational function, and you know a rational function is that function in which numerator and denominator are some polynomials in x, and regarding polynomial you have read in class 10th. So when your particularly expression is of the form numerator upon denominator, and denominator can be factorized into simplest factors, then always this method of partial fraction is applied. Actually, partial fraction means breaking a fraction into number of fractions so that its sum is given fraction, and then in place of, if your whole fraction is not integrable, then you can directly apply integration to find the integration of these partial fractions so that they can be integrated easily. So here we will do an intermediate process called integration by partial fraction method. So first you have to follow certain rules before dividing a fraction into partial fractions, and here as I have written, for integration of partial fractions we should have our numerator and denominator as some px and qx, where px and qx are polynomials, and then we apply this method when denominator can be factorized into simplest real factors. The following steps are used to find integration by partial fraction method. So first step, you have to check this. Degree of numerator must be smaller than denominator. This is very important point. Before dividing a fraction into partial fraction, this step is very important. The degree of numerator should be made smaller than denominator, and if it is not so, then divide numerator by denominator until degree of remainder becomes smaller than divisor, and then write your fraction as quotient plus remainder upon divisor, that is denominator. Then second step, write all factors of denominator, that is simplest all real factors of denominator. Then step 3, for each linear factor take numerators as constants. This you have to follow. That will be more clear by examples as constants a, b, c, d, so on, etc. And for each quadratic factor, maximum you can have a quadratic factor in the denominator. So for any quadratic factor, the numerator, its numerator will be taken as ax plus b type. Then step 3, you will find after that the value of a, b and c, these constant, and this will be explained to you through questions. And step 4, then substitute the values of these constants in the fractions, and then you will find that your each fraction is easily integrable, which you can integrate very easily. For example, I have taken here one example. Evaluate integration x upon x square minus 3x plus 2. So clearly I have taken first simplest example. You can see numerator and denominator are polynomials, so you can apply partial fraction method, and now you can write given fraction x upon x minus x square minus 3x plus 2. So first factorize denominator, degree is already checked as x upon x minus 1 into x minus 2, which is equal to a upon x minus 1 plus b upon x minus 2. Then equating numerators, after adding these two fractions, x will be equal to a into x minus 2 plus b into x minus 1. And now for the values of a and b, quickly putting x equal to 2 and x equal to 1, you will get b equal to 2 and a equal to minus 1. And then you can write your integration x upon x minus 1 into x minus 2 fraction dx equal to minus dx upon integration x minus 1 plus 2 into integration dx upon x minus 2. And now you can clearly see each fraction is now in the standard form, whose integration is minus log x minus 1 mod plus 2 log mod x minus 2 plus c. And now one question I have written for you. Evaluate integration x plus 3 upon x square minus 7x plus 12 into dx, and then tomorrow I will discuss more questions on partial fractions of different kinds. So make a note of it and show it to me.